Alright, so here we are. We're going to be learning today how to choose functions to model data, write some functions to model data, compare functions using average change, and solve real-life problems involving function types, and choosing functions to model data. So here is one core concept. What is a linear function, an exponential function, what is a quadratic function, right? So we've done all three at this point. Here's an example of each one. Alright, so we've straight lined the exponential function, and now the one we just learned recently is the quadratic function. Alright, and what I want to ask you guys to do is, rather than just being able to identify them by looking at them, right? Hopefully you can see these three functions and say, okay, that one's linear, this one's exponential, and that one's quadratic. Can we look at these functions in a different way and be able to decide if they're linear, exponential, or quadratic? Alright, and linear functions have differences are constant, the exponential functions have a common ratio, and then the quadratic function says the second difference is a constant. Let's see what that all means, alright? So here's an example of all three, right? So here's our x values, here's our y values. Our x values here are increasing by 1, 1, 1 all the way through. And I'm going to look at this model here, and again, increasing by 1, 1, 1, right? So no tricks, nothing to hide here. We're just looking at functions as some things they all have in common. Their x values are all increasing by 1 each time. Alright, so here's the three functions we have, right? A, B, and C. And then given to you in a table, and I'm going to tell you that one is linear, one is quadratic, and one is exponential. So which one's which? Well, as the x values are increasing by 1, what's happening to my y values here? Alright, so my y values here, I'm going from 11 to 8, so okay, that's subtracting by 3 is one option here. I can multiply this by something to get to 8 and see if that works, but 8 to 5 is also subtracting by 3. Well, so far so good, minus 3, up, again minus 3, up, and one more time minus 3. So this one is subtracting by 3, and according to this, the linear function, the first differences are constant. So, right, so I'm taking the difference of my y values as my x values are increasing by 1, and it's consistently subtracting 3. Right, so we talked about when you're adding or subtracting the same amount each time to the y value, then this is definitely linear. Right, the next function here, I'm going from 1 to 2. So I could be adding 1 here, obviously, or 1 to 2 is either multiplying 2, okay? Then I'm going from 2 to 4. Well, the adding 1 no longer works, so that goes away, but the multiplying by 2 still works, and the 4 multiplying by 2 still works, and the 8 multiplying by 2 still works. And we talked about this one, and this is multiplying by 2 here, and the consecutive values have a common ratio. So the common ratio here is I'm multiplying by 2 every time, and this is our example of an exponential function. And our last one. So we did linear, we did exponential. This one's going to be quadratic. But let's see what's going on here. So I'm going to come back to definition here. So the quadratic second differences are constant. Alright, so let's see that second differences. So -1 to -2, I'm subtracting 1. -2 to -1, I'm again subtracting 1. -1 to 2, I'm adding 3. 2 to 7, I'm adding 5, and that looks a little funky there. And so I'm going from -1 to -2, and so how do I get there? I could subtract 1 or multiply by the definition. Definition already told us that the second difference is, so I'm going to stick with the differences here. So I'm subtracting 1, then I'm going from -2, so that's how I get there. Then from -2 to -1, oh sorry, I'm adding 1 here, and then I'm going from -1 to 2, so I'm adding 3 here, and then I'm going from 2 to 7, and I'm adding 5 here. Okay, so really there's no pattern that's going on here, and this is where the second difference comes in. So if I do that a second time, well, how do I get from -1 to 1? Well, that means I'm going to be adding 2. How do I get from 1 to 3? Well, 1 to 3 again is adding 2, and how do I get to 3 to 5? And again, that's adding 2. So this piece here, so this one is the first difference, and that's how I would tell if it's a linear or not, right? If the first difference is constant, and then that would be tell us linear. But this in this example, is the second difference is constant. And when that happens, then this is an example of a quadratic function. Okay, so there's a quick little example of linear, exponential, and quadratic functions either from a graph or a table. Alright, and then that's pretty much it. Alright, good luck on these exercises. Talk to you soon.